In this lesson, we're going to look at a few things that help us better understand the ideal gas equation. So the first thing we have to worry about is when we're doing ideal gas problems is that the temperature must be in units of Kelvin. So we have to know how to get between Fahrenheit and Celsius, which we've seen before, and we need to add in one more type of conversion, which is how to get from Celsius to Kelvin. And this is a pretty easy conversion because we simply add 273.15 to the temperature in Celsius. On this picture, what we can see are the different temperature scales. And what we notice is that the 0 degrees Celsius, 32 degrees Fahrenheit, and 273 Kelvin are all equivalent to one another. Note that there is no negative values in Kelvin. When we talk about Kelvin, it's simply Kelvin, whereas degrees Celsius and degrees Fahrenheit are referenced in degrees and can both have negative values. So this picture just gives you a little perspective on how these temperatures are related to one another. For example, when we look at body temperature, we see 98.6 degrees Fahrenheit, 37 degrees Celsius, and 310 Kelvin. When we look at the ideal gas equation, we see that there are direct and indirect relationships. And what this tells us is that for a direct relation, as one value goes up, the other goes up. For an indirect or an inverse relationship, as one goes up, the other goes down. So to take this a little bit out of the chemistry world, let's look at a couple of examples here that better illustrate this point. We see that we have fruits and vegetables consumed on the x-axis, and on the y-axis we have life expectancy. Notice that as the fruit and vegetables consumed increases as we go to the right, we also see that life expectancy increases as well. So this would be an example of a direct relationship. In the right panel, what we see is that as the number of cigarettes smoked per day increases as we go to the right, the life expectancy in years decreases. Okay? This is an example of an indirect or an inverse relationship. So when we look at the variables in the ideal gas equation, we're going to see a few things. We're going to see pressure, volume, moles, and temperature. And all of these values can be measured or calculated for each sample in the gas phase. But what we want to look at here is the direct versus the indirect relationships between these variables. Notice here on the left, we have volume increasing and pressure decreasing. So that's an indirect or an inverse relationship. So as the pressure goes down, the volume goes up. On the right side, what we see here are two examples of direct relationships. So we have our temperature in Kelvin increasing and the volume increases. As the moles increase, so N stands for moles, the volume also increases. And this shouldn't be surprising. If we're blowing up a balloon and we add more moles, the volume is going to get bigger.